Alright, this is section 13.4. This is problem number 9. Y equals 7 minus 2x to the 4th. Let's take the first derivative. That's going to equal negative 8x cubed. And so there's only going to be one critical value here, and that is... Hold on, did I write the... No, I wrote the function down right. So yeah, there's only going to be one critical value, and that's when x equals 0. So let's evaluate the second derivative when x equals 0. Y double prime equals negative 24x squared. When x equals 0, the second derivative is 0 as well. And so the second derivative test is not going to help us in this case. We're not going to be able to figure out if 0 is a relative max or a min. So we have to go back to the method we used in 13.1 by looking at the intervals for the first derivative from negative infinity to 0 and 0 to infinity. And we're going to evaluate negative 8x cubed. So let's say x is negative 1. Negative 1 times negative 1 is 1 times negative 1 is negative times negative 8 is going to give us a positive. So the first derivative will be positive. And then evaluating the interval from 0 to infinity, we have let's try 1. So plugging in 1, we're going to get a negative. So because the slope of the tangent lines changes from positive to negative as we pass through 0, that means 0 is a relative maximum. So again, if you have the second derivative equal to 0, the second derivative test doesn't work. And so you can turn to this method, or there's going to be another method I'm going to teach you next week that is also useful in these situations when the second derivative is equal to 0.